Hi, you guys. Let's talk about properties of matter. So, an element's properties depend a lot about how many valence electrons that element has. We'll talk about that more in a minute. But as you remember from previous lessons, the periodic table is already set up to kind of group elements together based on their chemical properties, their properties of matter. So let's talk about that, about how they're grouped again, just as a nice recap. So remember, groups and families. Those words can be interchangeable. They're the vertical columns on the periodic table. You can see if you look at your STAR 8th grade science reference materials, the periodic table that you're given there, they're already numbered for you. So you've got 18 different columns here, all the way over here to 18. Okay? So those are the groups and the families. Now the periods are also numbered for you. They're 1 through 7 and they run horizontally. Okay, so there's 7 rows that go through the periodic table. Now, as I just mentioned before, the periodic table and the elements within it are arranged by their valence electrons according to their chemical properties. So what that means is you know that when we draw out or illustrate an atom, that the valence electrons are those electrons that are on the outermost ring. Okay, so they're the ones on the highest energy level on the outermost ring. These are the ones that are involved in chemical reactions. Remember in a previous video, I told you that valence electrons for Velcro, they're the ones that like to sucker themselves to another atom to try to bond with it. Okay, so they're involved with chemical reactions. Now, an atom that has a small amount of valence electrons or fewer valence electrons are very reactive. They're kind of bang, bang, bang. They're jumping around trying to bond with another atom. Okay? They're not very stable. They are ping-ponging around trying to bond somewhere because they only have one and they want to attach it somewhere else. Now, an atom with a higher number of valence electrons, they're more stable. They kind of move, but they don't really need to bond. They don't feel that need to bond, so they're stable. Now, they still can bond, but they are not as reactive as atoms with fewer valence electrons. And if you look at the periodic table, those are illustrated and outlined there for us. So in the first column, in the first group, we have all of these elements, and they have one valence electron. That's what this another number means. They've got one valence electron. In group 15, okay, all of the ones in this column, well, all of these have 5 valence electrons. Okay, so which would be more reactive? Group 1, because they've got less valence electrons. And the octet rule tells us that most atoms are happy with 8 valence electrons on their outermost shell. So this group over here at the far right, they're the happy group. They're happy with their 8 valence electrons, those outer electrons on that outermost shell. Okay, so let's just do some reminders. If we're talking about properties of matter, remember which type of property change does not involve changing one substance into something new. Does not involve. This would be a physical change. So if I take the notebook that I have in front of me and I rip it in half, it's still a notebook. It's just smaller. It's in smaller pieces. I've done a physical change to my notebook, but my notebook is still a notebook, right? Which property of or change does involve changing one substance into something new? A chemical change. This would be baking a cake. I have dough, I have flour, I have butter, I have sugar, and all of these things combine together, react together to make something new, a cake that wasn't there before. Um, so something when something new is formed That's a chemical reaction. An example of physical change is like melting, evaporating, cutting, ripping my notebook. An example of a chemical change would be if something's burned. Evidence of this would be like the black char that wasn't there before, but now it is. That's an evidence of chemical change. Digesting food, the enzymes, the acids in your stomach that are digesting your food is a chemical change. Rusting, oxidation, these are chemical changes. So if we look on the periodic table, where are the elements with the same amount of electrons found? I just told it to you earlier in this video. The same amount of electrons found. They are found in the group. So if I have a group, they're all this. Whoa, that's a curvy line. All of this have the same amount of valence electrons. So they might have a different atomic number, like 87 and 11. So they have a different number of protons, but their electrons on the outermost shell, those valence electrons, are going to be the same. They're all going to have one valence electron. So our next question says, on the periodic table, where are elements with similar properties found? Well, remember, the valence electrons dictate the properties. So it's kind of a trick question. They're all also going to be found in the same group, right? If the valence electrons have similar properties, then the elements with the same amount of valence electrons will also have similar properties. Okay, so all of them in group 1 are going to have similar properties because they all have the same amount of electrons, of valence electrons. Just like the ones in group 17 all have 7 valence electrons, they're all going to have similar chemical properties. So on the periodic table, where are the elements in this with the same amount of energy levels found? Those are the periods. So a period, for example, period 4, this lets us know that there's going to be 4 rings, 4 energy levels. Okay, there'll be 1, 2, 3, 4. So 4 rings, and on the outermost ring, this element here is going to have 7 electrons. So you can kind of cross your way through the periodic table to determine, okay, it's going to have 4 energy levels, and on that outermost energy level, 7 electrons. It's kind of like a graph. Okay, and then finally, on the what about an element determines its chemical properties? Well, remember, we're talking about chemical properties, similar properties. Valence electrons tell us the chemical properties of every element. So how many valence electrons it has lets us know, is it going to be reactive? Is it going to be stable? Remember, the least amount of the least amount of valence electrons are going to be reactive. And then if they've got more valence electrons, they're going to be stable. Okay, I hope this makes sense. If you have any questions, feel free to reach out. In summary, valence electrons determine chemical properties. Okay, the fewer valence electrons it has, the more reactive it is. The more valence electrons it has, the more stable it is. We can find the amount of valence electrons in the groups on the periodic table. And we know how many energy levels an element will have if based on its row or period in the periodic table. Okay, so for example, let's do another real quick one. I know that this element, let's say this one here, is going to have 3 energy levels, and on that outermost energy level, it'll have 5 valence electrons. Okay, If you have questions, reach out. I'm always happy to help, and I'll see you soon.
All right, and now we're going to talk about how matter changes. Now remember that we can have physical changes and chemical changes, and we'll talk about both of those now. So physical change is a change in shape, in size, in color, or in state, meaning solid, liquid, or gas. So a physical change is a change that does not change in chemical composition. Okay, so examples of this would be tearing paper or cutting your hair or an ice cube as it melts. Water evaporates while boiling. Let's look at these last two examples a little bit more closely. So you have H2O, which is a water molecule. You all know this. H2O can be frozen into ice cubes, but ice is still water, so its chemical composition is still H2O, even though it's in a solid ice cube. And as it melts, the state of matter changes, and that solid ice cube becomes a liquid, H2O still, right? We haven't added anything in, taken anything out. It's still H2O, it's still water. When we boil water, and water begins evaporating, that H2O molecules change state again, and they change now into a gas. If you look at a gas molecule of water, it's still H2O. Again, we haven't taken anything out, we haven't put anything back in. So this would be an example of a state of matter change or a physical change. Okay, physical changes are not indicative of a chemical reaction. Just because we see a physical change does not mean that a chemical reaction has also occurred. So, physical changes could be melting, freezing, evaporating, or even condensing. Remember that there's no change in bonds. They do not break or form new bonds between atoms or changes within the nuclei, okay? So there's no new compounds or elements that are formed, and changes in the speed or spacing of particles with no changes in bonding. So look here. We see that in a solid, we've got all the spacing between the molecules are going to be super close together. In a liquid, they're a little bit further apart, whereas gas, they're even further apart. Okay? All right. So now let's look at a chemical change. Chemical changes are changes in which a substance becomes another substance and it has different properties, or it's a change that is not reversible through any ordinary physical means. We can't undo it once it happens. So examples are mixing vinegar and baking soda. Once we mix these things, we can't undo it. We can't take it back apart and have vinegar and baking soda again. Okay, once it's mixed, it's mixed. Are burning a piece of wood. Once a piece of wood is burned, you can't undo it. Okay, so it's going to have a different property on it. Or soured milk. Ooh, soured milk. Or a rusted nail. Once these things happen, we can't undo it. It's not reversible. Okay, digesting food. Also evidence of a chemical change. Now, digesting food is when we're talking about actually the stomach acids that are breaking down your food for you. That would be a chemical change when the acids combine with your food to break it down. Okay, now I will hear a lot of debate over digesting food. If we're talking about chewing our food and breaking it into tinier pieces, that might be more of a physical change. In this regard, we're talking about actually digesting it in your stomach. Okay, so remember, a substance is made up of one type of atom. A compound is more than one type of atom, and they've been bonded together. A molecule is a group of atoms that are bonded together. We're going to talk in a next lesson about compounds versus molecules, so be on the lookout for that. Okay, then we've got a mixture. A mixture is a combination of two or more elements or compounds that have not reacted to bond together. So they haven't gelled, they haven't reacted, they haven't created anything new, but they exist in the same space. Okay, so remember that the properties does not change or involve changing from one substance to a new substance would be physical. And then the type of property that changes that does involve changing into one substance into something new would be a chemical. Okay. Examples of a physical change: melting, evaporating, cutting. Examples of a chemical change: burning, digesting, rusting. Okay, if you have any questions about this, please reach out. We're happy to help. Good luck.